we pick to the R here? Did we finish that? No? Okay, so what about the first one? So du would be negative 2 sine of x times negative 1 or something like that. So positive 2 sine of x sine of theta. Be theta. Does that make sense so far? Divide by the 2 sine of theta. So I get 1 over 2 sine of theta du equals d theta. Now I'm going to rewrite the integral using my u substitution. So it is the integral of u cubed sine of theta times 1 over 2 sine of theta d u. Any questions so far? It was a good choice for you because du showed up again, right? In that big U, du sine of theta showed up again. Therefore, the sine of thetas cancel. And this is 1/2 the integral of u cubed du. I can anti-differentiate u to the 4th power divided by 4. I go too fast. So I get u to the 4th power divided by 4. The 1/2 is still out there. Let's see. So 1/8. And what is u? Any questions about that? Any guesses on what to pick for you on the next problem? Remember, since it's a quotient, we've got to do some sort of u substitution. L of x. What's the derivative of L of x? 1 over x. Is there a 1 over x sitting there as well? Good pick. Right? If the derivative shows up again, remember that's a good choice. So I'm going to let u equal natural log the absolute value of x. du would be 1 over x. So dx would be x du. I could include it and it actually would work fine, but 2 is just a constant, so it would be unnecessary. In fact, when I rewrite this with using it, I'm going to pull the 2/3 out of the way because I can't write those constants are unimportant. Does that make sense? The constants I could deal with without a use substitution. From the property of integration. And then ln of x is u. X is still on the bottom. X dx is x du. The x's cancel, which is wonderful. If they don't, that's a big problem, right? The x's don't cancel. I can't do this. I can't work with an integral with 2 different variables involved. So they have to cancel. So the antiderivative of u is good. U squared over 2. Raise the power by 1 divided by the power. So that's 1/3 natural log the absolute value of that squared. Any questions about that one? The next one, what am I going to let u be? X squared of x. That is definitely a more complex piece. 3/2. For DUB. 3/2 x to the 1/2 dx. Is that exciting? Why is that exciting? Because there's an x to the 1/2, and there's the square root of x in the function. So remember, if that derivative shows up elsewhere in the function, that's how we're going to get that cancellation. So 2/3 divided by the x to the 1/2, something like that. Du equals dx. Something like that. So my integral of the square root of x e to the u times 2/3 x to the 1 to not x to the 1 half. Am I going too fast? Are we okay? Will y'all let me know if I'm going too fast? The derivative. So the derivative of x is 3/2 bring the power to front. This one just came from the derivative. Oh, are you talking about the x to the 3/2? At the very beginning? This is x to the first and x to 1/2. And if I add those together, you get x. So you can add those together. The square root of x's cancel. And so I'm left with the integral 2/3 e to the u du. Probably the easiest derivative of the integral you know, because the derivative or the integral of e to the u is u. So I get 2/3 e to the x square root of x, or you could have written x to the 3/2 power. Any questions about that? Last one is the hardest substitution problem that exists. If you were a normal AB class, I would tell you use substitution is our only option. Now later you will find some other options, but at this point use substitution is all we have. So if they give us this problem in AB calculus, we know that it can be done with use substitution. But it's not pretty. Because if I let u be 4x minus 5, what's du? 4, not 4x. And that's a problem, right? So maybe it can't be done, but I'm sure going to try. Again, at this point, you know that if I give you a problem, somehow it can be done with these substitutions. So we're just going to try. U equals 4x minus 5. That is the more complicated portion. I'm just going to wing it. Hopefully it'll work out. It won't work out pretty. Du. So you did think you were good. Make sure you pay attention to this one. This one's a special case. Du is 40x. Any questions so far? I can rewrite that integral as x times u all u's. May or may not be helpful, but I can. So I get the integral of u plus 5 over 4 u cubed 1/4 du. Getting rid of some constants. Do you agree that I can pull the 1/4 out front and get 1/16? Integral of u plus 5 times u cubed du. Still can't do that integral the way it sits, but what can I do now? Distribute the u cubed, and then I can. So what this u substitution did is it changed where the cubic was. Took the cube part and made it just a u, and the non-cube part made it messy. So it was still actually really helpful, kept us from having to cube, and I know cubing would have been possible, but you can imagine what I could make it that wouldn't be possible to do. Well, to do anyway. I guess not possible is a bad way to say it. You wouldn't want to. Yes. It will even be on your mastery. Any questions so far? So, if you have one that doesn't work out, at this point you know that there is a way to make it work out. So this is a little trick we can play. We can substitute. If there's an x left over that we can get rid of, we can go back and solve for x and substitute that back in and still get all u's and hope that it works out. This is our last resort. We try another u first, right? If there's another u to try, if we can think of any other u that might help us, we would rather do that. But this is our last resort if we must. Then one last step. What was our u? For x minus 5. That one was the bad one of the day.
Quickly goes.
Yes. Let everyone finish writing. I'll go back and say it again.
So we don't have to go
No, you could. Either way, you can parenthesis it or you put it in. That would be the same answer. Now, if you put the 16 with the c, the final 2, it just doesn't matter because c is constant. 16 is constant, still a constant. So, just not a big deal.
Where did you get the 5 divided by 4?
This one, 5 here.
So you just raised that one power.
And divided by 2.
Oh, okay.
Any questions about that? Okay, so let me walk through the steps of that again. The beginning steps are the same as any other u substitution. Take the most complicated part, call that u, find du. The way that you know this is a bad problem is when you see that the du doesn't have that other piece in it. It doesn't have the x. Now, if this had been a 4x dx, it's an easy problem. X would have canceled. We would have been done. The problem was that there was no x that showed up at the du. So that piece didn't cancel. Again, if this happens, glance at the other possibility for you. Make sure you didn't just pick a bad u. But on this one, if I did dx, it would just be 1. Neither way is going to get rid of my other piece of the function, so I'm just stuck. So when I see that happen, I go ahead and do my u substitution. But then I'm going to go back and solve for x in my u substitution and replace that x with u's. Does that make sense? Because remember, I cannot integrate du if I have an x involved, so I've got to get rid of that x. So I went and found that, and it was u plus 5 divided by 4. Then you can simplify integrate. Make sense? So this is the worst of the worst as far as u substitution goes. You Okay? And then the last question on it we haven't done yet either. But you can go ahead and start looking at those two and kind of see what your first mastery exam is going to look like. Because of the way this chapter's set up, you won't get to take your mastery exam before the exam. In fact, your mastery exam will be the first day of the exam, but you can retake it. I will tell you, the people who did well on the mastery exam, of course, did well on the test. So you might need to do a little work up front to do well on that mastery exam the first time. I'm not saying you have to master it the first time, but to at least go, okay, I know what I'm doing. You know what I'm saying with that? With derivatives, I gave you the derivative mastery exam 3 weeks before the derivatives test or whatever. But by the time you got to the derivatives test, you knew how to do derivatives. I can't do that with this integrals test, or you wouldn't have a test in the first quarter. So, not really, but so make sure that you are prepping for that before this first test. Okay? Understand?